Math in nature, more specifically, caves. You see, I wasted a very long time trying to think of a cool intro, and that just wasn't happening. Math, caves, nature, it's just, no, there's no correlation. So, this is the best I got. Nope, not doing that. Before diving headfirst into a cave, it's best to understand how caves are formed, and that starts with these guys right here, and these guys. Oysters, clams, mussels, and coral. When these guys die, their shells litter the ocean floor, releasing calcium carbonate. Once this process has repeated itself thousands of times, the calcium carbonate will crystallize and harden. This forms limestone. Over hundreds of thousands of years, the acidity in groundwater and precipitation eats the calcium carbonate away, forming limestone caves. There are many other types of caves, but for the purpose of this video, I will be focusing on these type, otherwise known as solution caves. So, caves. Why do you care? Well, you probably don't too much, but they are pretty cool. People have explored and utilized caves for as far back as human history goes. In fact, caves can often be gold mines for archaeologists. The oldest skeleton found in the Americas was submerged in the caves of Quintana Roo. The skeleton's between 13,300 and 13,600 years old. In fact, the world's oldest rock art was found in a cave in India. I'm not even gonna try and pronounce that, but the so-called rock art is over 700,000 years old. And here's a picture of that. I would strongly debate whether that is art or not. That looks like a hole to me, but whatever the experts say. The way scientists are able to determine the age of these artifacts is with the process known as carbon-14 dating. All organisms contain carbon-14 and carbon-12. Carbon-14 is radioactive and remains constant due to changes with the atmosphere when the organism is alive. When the organism dies, no more carbon-14 is exchanged and it begins to decay at a constant rate. Carbon-14 has a half-life of 5,730 years, while carbon-14 remains stable and doesn't decay. Knowing this, scientists can determine the age of a once-living organism by measuring the radioactivity of the sample and comparing it to the levels of carbon-14. Although this process is very accurate, it has its limits. Due to carbon-14's half-life, it can only be used to date back to around 50,000 years. Well, remember that rock art? It's over 50,000 years old and it's not organic. Scientists must use a different method for determining the age of rocks. One way to accomplish this is scanning for uranium-238. Uranium-238 has a half-life of 4.5 billion years and has been used to date the oldest rocks at 3.3 billion years old. This process is similar enough to carbon-14 dating, so I won't bore you with the in-depth details. So, before scientists and archaeologists can get in there and do their science stuff, caves must first be mapped and explored. That's where these wonderful people come in. You see these people right here, they're a little crazy. They like to map caves for fun. Mind you, some caves are like very, very small. And these people just crawl on the ground in the dirt like worms, recording their progress, trying not to die. The mapping process is relatively simple and has remained the same for the past 250 years. I was able to read about the topic, but there wasn't an in-depth explanation of the process, so I wasn't able to explain it well. So I relied on the best learning platform there is, YouTube, and I found this dude. This dude, Mr. Derek Bristol, has a great video of the process. He's also the person who recorded all of the caving footage I'm using. Don't worry, I asked him, he said it's okay. Anyways, this process can be done with one person, but is much more efficient with two people. One to record data and the other to help with measurements and designate mark points. The team will record the distance between 2 points. They will then measure the azimuth, the inclination, and the vertical drop or gain. They will then repeat this process until the team is satisfied. They will then take this data and can put it into specialized cave mapping software, which will create a digital map. So that's cool and all, but I'm running into a critical issue here. You see, this video is supposed to be 7 minutes long, and currently it's only 5. Not to mention this video is kind of boring. So, out of curiosity, I decided to look up caves in Georgia. Found this place, Ellison's Cave. Looks really, really cool. And I also found this place, Pettyjohns. So I looked up Pettyjohns just out of curiosity. Oh, it's only an hour and 30 away.
Dude, it's dark. I'm not with this. I'm not with this.
Bro, come on. We're already here.
It's dark, it's cold.
Bro. This thing's huge. Oh my god. Doing this project, I was like, going into a cave. It can't be that hard. Surveying a cave, that's a good idea. Now, guess we're going down that way.
No other way. I might have to get able to do this work. Get out like you can. Real muddy.
I'm gonna go that way. What you think about that?
Sounds great.
Hold on, bro. I need to get the... Check this out. 20. Alright, what'd you say it was 13.14, 15 feet? 15? No answer? Okay.
I apologize as my drawing skills are non-existent, but the circles represent rocks and the black circles represent a sinkhole within the cave. First, we went to the very back of the cave, which was about 500 feet in length. Then we descended down the sinkhole, which was about 25 feet. This led us to a declining hill, which was about 50 feet. And then we went down a tunnel for about 200 feet, which led us to that very tight squeeze, which only had about a foot, 2 feet.
How do people do that shit? It's like, I don't know. You seen that? Probably, you know.